In this example, we have a poem with 20 lines. So imagine that this right here is a sheet of paper and a poet has written a poem on it that has 20 lines. Now remember, or think about if you've ever read a poem, often poems don't have correct punctuation. They don't even have complete sentences. So it's possible that some of the lines may not have verbs, some of the lines may not have adjectives, some may have both, some, so it's just we have 20 lines here, 20 lines or something, right? And each of these lines is got some English language written on it. All right, so our poem, for this example, has a verb in 12 of its 20 lines, an adjective in 10 lines, and both a verb and an adjective in 5 lines. And we want to know how many lines have a verb or an adjective in them. All right, so we'll rephrase this in the language of set theory. Let's say that A is the set of lines that have a verb. Say that B is all the lines of the poem that have an adjective. All right, so then from the statement of the problem, a poem has a verb in 12 of its 20 lines. So then we know the cardinality of A is 12, and the cardinality of B is 10. And because it says there are 5 lines that have both a verb and an adjective, that tells us that the number of lines, so cardinality, the number of lines that have both a verb and an adjective, so A intersect B equals 5. Now, we want to know how many lines have a verb or an adjective in them. So what we want to know is the cardinality of A union B. Well, we have a formula for this. That's the inclusion-exclusion principle. So this is the cardinality of A plus the cardinality of B minus the cardinality of A intersect B. From above, we know the cardinality of A is 12, the cardinality of B is 10, and we subtract 5. So 12 plus 10 minus 5, 10 minus 5 is 5, so 12 plus 5 is 17. And that's how many lines have a verb or an adjective in them.